All right, I'm going to do problem number 49 on page 845. This is a geometric series. We want to find the sum of the infinite geometric series. There's actually a formula for this, but before I do the formula, let's just find what the equation is for the actual sequence that we see here. Okay, when you look at this, we have alternating signs. Okay, we got a first term of 1, we got alternating signs, and it looks like we have multiples of 3, or multiples of 1/3 when you look at that, because 1/3 to the first power is 1/3, 1/3 to the second power is 1/9, 1/3 to the third power is 1/27. So actually for the series here, let me get my marker working, a to the nth power is going to be your first term, 1, times my common ratio here is negative 1/3. And that's raised to the n minus 1 power. So that's what my sequence looks like. Now there's a formula that was in your book that tells you how to find the sum of an infinite series. This is an infinite geometric series. There's a formula for that. It says the sum of an infinite series is going to be your first term over 1 minus whatever your common ratio r is. Negative 1/3 is my common ratio. A is my first term, which is 1. So I got to use this formula to figure out what this whole thing goes to. So my sum is going to be 1 over 1 minus negative 1/3. So if I do 1 minus 1/3, 1 minus negative 1/3 on the bottom, so you'll have 3 over 3 plus 1/3. So that equals 1 over 4/3. There should be a 3 here, sorry. 1 over 4/3 is the same thing as 3/4. So this whole sum, even though these numbers go on forever and ever and ever and ever and ever, the actual sum of that infinite series approaches 3/4. So 3/4 would be your answer for number 49. You do the same thing on number 48, which is actually the problem that I assigned for homework. So if you're having trouble on number 48, follow the steps that I did here to get your answer for number 48. It's pretty much the same problem, just different numbers.